Okay, welcome back. We are going to learn about the law of sines today, and it's really straightforward. What we're talking about here, the idea here is we've been working with right triangles. We've been using trigonometry, sine, cosine, and tangent for right triangles only. But you can actually use those same functions for non-right triangles, but you have to do it in a little bit different way. Okay? Today we're going to learn about the law of sines. Next lesson, we're going to learn about the law of cosines. And here's what it says. If you know the measures of two angles and the length of a side, angle, angle, side, or angle, side, angle, or two side lengths and the measure of a non-included obtuse angle, side, side, angle, then you can find all the other measures of the triangle. The reason that we can't use side, angle, side, as you'll see in a minute when I put it here, is that we don't have a pairing of a side and its opposite angle. So here is the law of sines. Check out what's going on here. Okay. For any triangle A, B, and C, we are going to call the lengths of the sides opposite. For example, here angle C will be side C. Okay. This is a capital letter. This is a lowercase letter. So we've got the sides opposite angle A, B, and C are little a, little b, and little c respectively. Okay, so the little a side goes across from big A angle. Okay, then the law of sines relates the sine of each angle to the length of the opposite side. Remember, sine is a function in your calculator, and you can find that out by typing it in if you know that angle. Okay, we can also find it if we don't know it. So basically what we need is we need two pairs of angle opposite side, like that, angle opposite side. This is why we can't use up here where it says side, side, angle. We can't use side, angle, side. Okay, you see that it doesn't say side, angle, side, because what we'd have there would be two sides, and then this angle that we're talking about would not be opposite one of those sides. Okay, so that wouldn't help us. So let me just erase this. What we need to have actually is either angle, angle, side, angle, or side, side, angle. Okay, if we have that, we can set it up like this. Basically what you get is the ratio of the sine of the angle, the sine of this angle, over that opposite side length will equal the sine of this angle over that opposite side length, which will also equal the sine of this angle over this opposite side length. Okay? And that works. What you're really going to end up with is either just, or you're going to end up with two of them functionally when you're doing this. You're going to have something like this. Okay? Sine A over, sine of angle A over the length of side A equals sine of angle B over the length of side B. Okay, you won't do all three of them, but you can set sine of A over A equal to sine of C over C if you wanted to. You can pair them up anyway. These two can go together, these two, or these two. Okay, that'll make a little more sense hopefully in a bit when we do it. Now, the question is, why does it work? Okay, so here's why it works. If you were to draw this altitude and just follow the math here, it's pretty straightforward, I think. Okay. If you draw this altitude down and you just call it h, right? There's this value d here. I mean, this vertex now d, and you form two right triangles here, 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 here. Okay. So the sine of this angle A for this little triangle, sine of it is going to be its opposite side length, h, over its hypotenuse b, h over b, right? And the sine of this angle b will be its opposite side length for this right-hand triangle, this opposite side over the hypotenuse of a, h over a. So that's what they've written here, okay? They've just set up the sine ratio of sine A is opposite over hypotenuse, sine B is opposite over hypotenuse when you split this into two separate smaller triangles, right? Now, what they do here is they say, okay, let's take this thing and multiply both sides by b. Now it's off the bottom, and it's multiplied over here. Do the same thing over here. Multiply both sides by a. That will cancel it from the bottom of here and multiply it over here. And then this is a new equivalent equation, right? Now, notice that they're both equal to h. H is that same length for both of them. Since they're both equal to h, through the transitive property, they're equal to each other. So b times the sine of a equals a times the sine of b. Now, if you divided both sides by b, it would cancel out here and put a b on the bottom here like you see. If you divided both sides by a, it would cancel it out here and put it on the bottom here. And essentially what you're doing here is if you divide both sides by b and then divide both sides by a, you end up with this, where the sine of a, the angle a over the side length a is equal to the sine of angle b over the side length b. Okay? And that works all the way around because you can draw an altitude anywhere from here to here, from here to here, whatever. Okay? So it will work for sine of c as well. That's the big idea. So what you're really going to be doing is having 3 of the 4 pieces of information of a ratio that you might have like this, and you're just solving for the missing value. So we're going to put that into play, but that's the big idea. Okay, so here's problem 1. In triangle ABC, measure of angle A is 48, measure of angle B is 93, and side AC is 15. To the nearest tenth, what is the length of BC? Now, it'd be really convenient if we kind of had that diagram, right? So how can a diagram help you solve the problem? Well, you can visualize it if you draw it out, but you need to draw it carefully and you need to label it because if you put something in the wrong place, that is definitely not going to be helpful to you. So let's do it. Okay, draw and label ABC, and pretty straightforward. You just draw triangle ABC, and then you fill in the information. Measure of angle A, 48. Measure of angle B, 93. AC, 15. They're asking about BC, so let's just put a little mark here for BC, which is this one right here. I'm going to call it X. And notice what you've got here. Then you've got an angle opposite side pair and an angle opposite side pair. When I say you've got it, I mean you either have that information or it's something you're looking for. Okay, so to go like I'm going to count this as something that's valuable to us because it's one of the pieces of information we need to include even if it's a variable at the moment. Okay, so how do we set it up? Well, we can say, remember, sine of this over this equals sine of this over this, and okay, you can see what they did is they did sine of b over b equals sine of a over a. The order of it doesn't really matter. You've just got to have, if you have the sines on top and the side lengths on the bottom, that's got to be consistent. And each of these ratios has to be a matching angle and side pair. Okay? So you write it out. How do you solve for that variable? Well, the variable, they're calling it actually BC. I put an X there, but I can write a little X in so you can just see it. We can call that one part the X. That's the X we're looking for, right? So how do you isolate that? Well, what you really need to do is just do the mathematics that will solve it for you. Okay, you would, well, there's a million ways you could do it. You could flip both of these things, take the reciprocal of them, but you can also multiply both sides by 15, blah, blah, whatever. If you don't know how to solve for that, if you don't know how to isolate the BC part of this, that's kind of a different conversation, okay? But essentially, you can see what's going on here is multiply this side by 15, so you get 15 sine of 48, right? You can multiply that side by BC, so it would be BC sine of 93 equals 15 sine of 48, and then divide both sides by sine of 93 to get that BC by itself. So all you then have to do is you need to use your calculator. You need to type it in. You need to say 15 times the sine of 48 divided by the sine of 93. And you might need to use parentheses around this. Say parentheses of all of that, parentheses of all of this. Okay, depends on your calculator. And what do? You work this out to be that. They're asking for the nearest tenth. And since you're rounding it off to this first place after the decimal, the tenths place, and this is 5 or higher, it rounds up to a 2. Okay, so what we get then is the length of BC is about 11.2. And you don't have units, so it's fine. Okay, you're going to do this now. You're going to calculate. Oops, sorry about that. What is AB to the nearest tenth? Now you're looking for this side length here. Okay, and just be careful. Remember what I talked about what information you have and what information you need, and there might be a piece of information you need to figure out. Little hint there. So pause the video now, do this got it problem, unpause it when you've got your answer. Okay, let's do it. So one of the important things to look for here is they're asking about AB. So where is AB? That is this side right here. Okay. Now, because we need to have a side and a matching angle, we are going to need to be using the sine of C. Okay. And we need another pair of angle and matching side, and that's going to be this pair right here. Okay. Let me write that better, like this right here. Okay, that is an angle side pair. Okay, and so since we're looking for this side right here, we need to be using this angle. But do we know that angle? Well, if you know two angles in a triangle, you know the third angle. Okay, so if we know that 93 plus 48 equals 141, then subtracting that from 180, we get 39 degrees. And so that's what angle C is. So let me erase the marks here. Angle C is 39 degrees. Okay, 39, whoops. And we're looking for this right here. We call it X. Okay, or let's just call it AB. Okay, so this is what we've got then. Okay, oops. We've got the sine of 39, sine of this angle, over its opposite side, which we're calling AB, equals the sine of this angle, 93, over its opposite side, 15. Okay, that's what we've set up here. Now, I want to isolate AB. That's kind of the variable, the missing value that we're looking for. Okay, watch what I'm going to do first. The first thing I'm going to do is I'm going to just take the reciprocal of both of these. Okay, I'm just flipped them both over because the reciprocals of two equal ratios are also equal. So I put the sine of 39 on top, AB on, I'm sorry, sine of 39 on the bottom, AB on top, right? Sine of 93 on the bottom, 15 on top. I just flipped them over, okay? Now I've got AB on top, and all I need to do is, it's being divided by sine of 39, so I need to multiply by sine of 39, and I've got 15 times sine of 39 over sine of 93, okay? And if we calculate that out, 15 times sine of 39, all divided by the sine of 93, and we round it to the nearest tenth, what we get is that AB is approximately equal to 9.5. That's how we do it. Okay, so as that last slide said, that you can find an angle from this as well. You set up the ratio and you use the inverse of the trig function in order to find uh, the angle. So check it out. In triangle RST, RT is 11, ST is 18, and angle R is 120. To the nearest tenth, what is angle S? So what you want to do is you want to draw a diagram here, okay? So here's the diagram over on the side, and then what it says is use the law of sines to set up an equation. What do we have? Well, the information that we have in terms of the pair, remember what I said, we need a pair of angle and matching side. We've got that angle and matching side, and we've got this angle and matching side. And when I say we've got it, what I mean is, let me mark it. When I say we've got it, it's one of the values we have, one of the values we want. Okay? So angle and matching side, angle and matching side. So we say the sine of this angle over its opposite side equals the sine of this angle over its opposite side. Okay? The one thing that we don't know is what that angle S is, so that's why it stays as angle S, but sine of 120 divided by 18 equals sine of S over 11. If we were to multiply both sides by 11, we would get 11 times sine of 120 divided by 18 would be the sine of this, okay? So that's what we do there. We multiply both sides by 11 to find this. And now, so we've solved for sine of s. Now what we need to do is we need to say, we need to hit that second button, or that function button. I forget what it's called on the TI-84. To get inverse of sine, it looks like sine raised to the -1 power. Inverse sine of this. Inverse sine of 11, sine 120, all over 18. Okay, that will produce it in the calculator for you. So like that, measure of angle S is going to be the inverse sine, or arc sine is how you'll hear it said, of this exact ratio. And when you work that out, or when you hit it on the calculator, you get this. They're asking to the nearest tenth. And what is in the tenth place? Well, what's in the tenth place is a 9. What's in the place after that? Well, is it 5 or higher? Yeah, it is 5 or higher, actually. It's 5. So what does the 9 go up to? It goes up to a 10, carry the 1. And so your answer then becomes 32.0. Now, couldn't you just call it 32? No, don't just call it 32. The thinking is this. If they want you to round it to the nearest tenth, and you put your answer as 32, which 32.0 is equal to 32, yes. But if you put 32 without putting the 0.0, it appears as though you didn't round to the nearest tenth. It appears that you rounded to the nearest whole number. By putting 32.0, what you're saying is, yeah, I did round to that place. It just happens to be a 0 there. Okay? So 32.0, if it says to the nearest tenth, you want to show what's in the tenth place, even if it's a 0. Got it? Okay. So here's your got it problem. In triangle KLM, LM is 9, KM is 14, and measure of angle L is 105 to the nearest tenth. What is the measure of angle K? You're going to pause the video right here. You're going to draw and label a diagram, and then you're going to set up the equation and solve it. Pause the video right now. Do that when you have an answer. Come back and check your answer against my answer. Pause it now. Okay, so here I've made my sketch. KLM, LM is 9, KM is 14, and measure of angle L is 105. And so what we've got is this pair here, and what we've got is this pair here. We're looking for K, measure of angle K, okay? So how do I set that up? Well, you say the sine of K divided by 9 equals the sine of 105 divided by 14. That's how they pair up. And then multiplying both sides by 9 to get it off of the left-hand side and isolating sine of K, we get sine of K is 9 times sine of 105 divided by 14. And if we then type that into the calculator, what do we get? Hold on just a second, let me do it. Okay, and what I should do is show you what it is that actually I need to do. So what we need to do here is we need to say then the measure of angle K is going to be the inverse sine, or arc sine, of that ratio. Okay, if we're trying to find the angle, we need to undo the sine part by doing the inverse of sine of that ratio. And when we do that and we round to the nearest tenth, we get the measure of angle K is approximately 38.4 degrees. Hope that's what you got. Let's keep going. Okay, so this one is just a real world problem. This is the last one we're going to do here just to apply this. So a ship has been at sea longer than expected. There's only enough fuel to safely sail another 42 miles. And so you can see the ship over here in the diagram. Okay, Port City Lighthouse, we don't know the distance. And Cove Town Lighthouse, we don't know the distance to there, but we do know that they are 40 miles apart from each other. Like that's an established distance. They're lighthouses, they're not moving. We already know how far apart they are. Okay. At sea, the captain can't determine the distances by observation, but can measure the angles. Okay. You can see that they're forming the lighthouse and the ship is forming a 52-degree angle here, a 70-degree angle here. Okay. Can the ship sail safely at either lighthouse? We need to determine these distances. Got it? Now remember, we can't use angle side angle generally. I'm sorry, we can use angle side angle. We can't use side angle side. We can use angle side angle because when we have two angles, we can find the third because we need this pair. Okay? We need that. We need one pair of, we know the angle and we know it's matching opposite side. Okay? Can we calculate this? So what this says is step one, find the measure of the angle formed by Port City, the cruise ship, and Cove Town. So essentially all you're doing is you're just taking these amounts away from 180, right? 180 minus 70 minus 52 is 58. So this angle right here is 58 degrees. Got it? Okay, that's perfect because now we have an angle and an opposite side pair. And then we can use that and this angle to find this opposite side, right? This angle to find this opposite side. So that's what it says here. You are going to then step two, use the law of sines to find the distances. And they're going to do it separately for each one. Okay, so let's just talk through what they did here. They said sine of 58 over that opposite side of 40, okay, equals, they're finding this side right here, the distance to the Port City Lighthouse, sine of 52 over, and they've called it D. Okay, so we'll just label it D. Let's put in a little D there. Got it? Okay. And, oh, actually, I think what they're using D for is the distance. So we're going to use D for all of it. So if we did this one first, we'll put a D there. We'll use D for the different parts. So when you do that, you say, okay, what is that length? Well, if you multiply both sides by D, it comes off of this side and multiplies by sine of 58. And if you multiply both sides by 40, that does the same thing here. Now we need to divide by sine of 58 to get D by itself. So you get 40 times sine of 52 divided by sine of 58. Calculating that out, you find that it is approximately 37 point blah, blah, blah. Okay? Doing it over here, I'm going to erase this D. We're going to do this. Oops. Erase that D. We're going to now do this distance right there. And what does it say? Okay, so now we're doing sine of 58 over 40 equals sine of 70 over D, that distance to Cape Town. Cove Town. Okay, so you multiply the diagonals. D times sine of 58 equals 40 times sine of 70. And we're all isolating the distance, so we divide both sides by sine of 58 right there, and you get then the distance equals 44 point blah, blah, blah. Okay, how does that help us? Well, if we now think back to the original problem, what we know is that the ship can go at most another 42 miles with enough fuel. So what we find here is that the distance from the ship to Port City Lighthouse is about 37.2. You're rounding it to the nearest tenth. And the distance from Cove to the Cove Lighthouse is about 44.3, rounding to the nearest tenth. Which one is less than 42? To Port City. So the ship can safely sail to Port City Lighthouse, but not to Cove Town Lighthouse. Yeah, that's how you do it. Let's do the got it problem. So this is a baseball problem. The right fielder fields a softball between first base and second base, as shown here. Here's the right fielder. Here's first base and second base. You can imagine the diamond going here, right? Home plate, first base, second base, third base, home. Okay, so the right fielder's over here. Fields the softball. If the right fielder throws the ball to second base, how far does she throw the ball? What is this length right here? We've got this angle of 40 and this right here. Okay. We don't have this angle, but we do have this length. So we're going to need to find this angle because we need that pair. Okay. Do that. Solve this problem. You're going to pause this video and you're going to set it up as the law of sines ratio, isolate the missing value, What are we missing? We're missing a distance, and then you're going to come back, unpause the video, and see how you did. So pause it now and try this out. Okay, so I figured out that this is 72 degrees, right? And this is the length that we're looking for. So now we've got this angle side pair and another angle side pair. So how do we set it up? Well, we say the sine of 72 over the length, opposite length of 60 equals the sine of 40 over the opposite length of x. Now if I multiply the diagonals, I get x times sine of 72 equals 60 times sine of 40. And then if I divide both sides by sine of 72 in order to isolate the x, you get 60 sine of 40 over sine of 72. And calculating that out and rounding to the nearest tenth, we get approximately 40.6 feet. And let's just say, for the sake of argument, that if we aren't told what to round it to, we'll always round it to the nearest tenth. Okay? And if the problem designates what to round it to, we'll round it to that. So I believe that's it. If you have any questions, you can email me or ask me in class. But yeah, pretty straightforward. Hopefully you made sense of this lesson. And yeah, the law of cosines, which is the next lesson, will be a little bit more complicated of a formula, but it's simply a matter of plugging numbers in and solving. So there's a lot of algebra and some trig calculations involved, but I think you can handle it. So good luck. Work on those IXLs and then work on the homework problems.